Now we can move to some kind of general introduction to this blockchain. Whether you have heard or you know some details or not, but this blockchain is something very interesting phenomenon in the area of IT. Some people call it revolutionary. Some people call it disruptive. Some people call it innovative. So everybody is excited. If you do search for blockchain, you will get 300 pages. Everybody is talking about it. Everybody is working on it. Papers, books, incubators, big companies. It's a tsunami. Some people call blockchain the fourth generation of internet. The first generation Windows. The second generation World Wide Web. The third generation mobile. The fourth generation that will revolutionize internet is the blockchain. So everybody is excited. IBM declared that they are reorganizing their company for the future to do only blockchain. Products, services, IBM is becoming a blockchain company. You will see next slide, blockchain of big banks. 40, 50 largest banks created consortium to do blockchain. Have you ever heard big banks jumping early into IT technology? Never. They always join last. Now they are leading. European Central Bank interested. Report of UK government. Report how the technology will go even beyond blockchain. IBM blockchain, banks blockchain, European Commission blockchain, UK government blockchain, banks blockchain consortium. SEC, the most conservative entity in the financial world, they will use blockchain. Credit Union, Nasdaq is switching to blockchain. So we all must say, what is this blockchain really? Why? What exactly is this blockchain? So basically this blockchain concept is shaking the world. In my experience, many people around the world, when it comes to people about blockchain, you can structure people in three groups. The first group, 90% of people. Second group, 9% of people. And the third group, 0.9% of people. The first group, 90%, are people who either never heard of blockchain or they have heard the keyword. I've heard, but I have no clue what it is. That's 90% of people. The group of 9% of people, second group, they know more than the keyword. They read some articles, they started their company, they're doing software, they know more than a keyword. This is a group of people who think they know blockchain, but as you will see at the end of my presentation, they don't. They think that blockchain is distributed database. If the blockchain were distributed database used in banks, then IBM installed the blockchain 25 years ago in all our banks. The third group of 0.9% are people who really understand what the blockchain is. So it depends. Do you think that you are in the first group or in the second group? I want with this presentation to take you into my third group today. Whether you are in the first group or in the second, or eventually in the third, that depends whether you can answer a couple of simple questions when it comes to blockchain. What is exactly blockchain? Can you tell me? So that's the first question. Blockchain. So what is in the block? Why block? Why blocking? Why? Next, why chain? Why chain? Why? Why not just blocks in the database? Why chain? Why is this revolutionary? We had earlier hardware servers, then we moved them into cloud. It was not revolutionary. It was just change of technology. But here, revolutionary. It will change the world economy. It will change how government govern. It will change how we handle money. It will revolution. So what is so revolutionary? How this blockchain really looks like? Structure, protocols, what is the essence? Why we should use blockchain? And what are significant benefits? If you don't have a clue as the answer to any of these questions, you are in my first group. If you know, oh, I know why we have to use blocks, I know that, and I know why we have to chain them, then you think that you know the blockchain, but I will tell you most probably you don't. And I will answer all other questions here about the blockchain itself. This blockchain as a concept, as the idea, as the approach, is a little bit strange. It is not like you have your hardware, move it into the cloud, so you say, okay. It is by telling you in 15th century the earth is not flat, it's rounded. So if someone would tell you that, you would say, oh, you must be crazy. It's like to tell you, Einstein, you know, the faster you travel, the slower the time. That's exactly the blockchain. Initially, intuitively, looks very simple. But it has essential philosophy in it, in its approach and so on. So if I would put now the slide of the blockchain and I go with my finger and I say this, this, and this, then I wouldn't give you the essence. So the best to give you the essence and the understanding of this blockchain is to actually give you an example of problems that this blockchain can solve and client-server or any other architecture cannot. So I will start with a small, simple application, and I will go through the sequence of problems, and I will build solutions, and along the way I will actually build my blockchain here. So this application that I will use is actually hypothetical. It's hypothetical, never happened, but bear with me. So here goes this hypothetical scenario. So a couple of weeks back, Seville calls me. She says, Professor, I'm the member of a group here in Stockholm. We meet from time to time and have some workshops. But we would like to organize a small application, which is actually an auction. We would like our members, they develop some software, some of them they have some papers. We would like to put that on auction by our members. Other members come and bid, and then the highest bid, winner, pay, exchange, report. So, Professor, can you do that for our group? Oh, so sure. So I spent a couple of days in my office, and I created a server. So I said, Seville, here is auction server, so you can come and use it. Oh, she said, very good, we will use it. So, group to my server, register, upload report, offer for $100, someone else, bid, 150, sold, 150, report. Simple, works very nicely. So a couple of days later, I call Seville. I say, how is my server doing? She says, it's kind of working. Oh, I said, what do you mean kind of working? Well, we have 3 very serious problems with your server. Oh, I said, simple application. What are the problems? She said the first problem is the server is very unreliable. It's down all the time, so we cannot use it. Second problem is when it's up, it's so overloaded and slow. You need 15 minutes just to enter transaction. And number three, by the way, it was hacked. So all our data, auction money, all... I say, Seville, I should look into these problems. So basically, I took these three problems, and then I think, what should I do about it? I say, first, server hacked. Sorry, Seville, I'm expert security. So I introduce cryptography, login, strong authentication, certificates, firewall, virus, malware, access control, VPN, strengthened it. So my server became very secure. Then I say about the other two problems, but they are basically also simple to solve. Instead of one server, I will introduce multiple servers. I will introduce 10. So if one is down, no problem, you transparently connect to the other one. And second, if one is overloaded, then you go to another one. So if I introduce distributed system, I have solved all my problems. But then I realized, wait a second, but my application now here actually will not work because it runs on a single server. So if I have multiple servers, then if you are on one of the servers and you enter your offer, then only people who are at that server, they can see this offer. So basically, I introduced multiple servers, distributed environment. And by the way, I have now restructured the group into subgroups. So one subgroup registered to one server. And by the way, of course, you understand, I had to tune my version 1 of my application now to work in the distributed environment. And this fix or extension is also very easy. You understand that? That is, if you enter here an offer, then this offer must be distributed to other servers, right? That's natural. And if over here you see the offer and you enter the bid, then the bid must be distributed to other servers. So I had to tune a little bit my application. So if someone enters an offer, $100, then the offer must propagate to all servers. And if someone enters the bid, it must propagate to all servers. In other words, it means if there is an update to any of the servers, then this server must distribute to all other servers, whatever the update is. And in our terminology, when one component sends message to multiple components, this is called broadcast protocol. So I said, wait a second, before calling Seville again, I have to tune my application to version 2 so that bids and offers will be distributed. With that, I have solved the problem server down, server overloaded, and also security. So I said, very good. I have actually created an auction ledger. Ledger. Ledger contains offers and bids. And by the way, my ledger is distributed. It is federated because these are individual groups, but they act as a total community. My ledger is synchronized, and my ledger is secure. And it supports broadcast protocol. I was proud of myself. Seville, I solve all your problems. Great, Professor. What did you do? I created distributed, federated, synchronized, secure ledger. And by the way, security, so it's private, only your group can use it. supports broadcast protocol. She says, like, sounds a little bit complicated. Are you sure that it really works? So I said, don't worry, you know, it's fantastic. Now system runs smoothly. Very good, very good. She said, okay, now we can continue use it. You wouldn't believe. 24 hours later, she calls me. What's going on, Seville? She said, you know, Professor, we have a small problem with your system. Oh, what problem? Yes, what's the problem? She said, you would agree that when auction goes, that every next bid should be higher than the previous bid. I said, sure, logical. By the way, Seville, I actually inserted test in my code. So when you say you want to bid, you get currently the highest, and if you put lower, the system will tell you cannot do it because you cannot bid lower than the highest. She said, yes, but that's what we all expect. But in your system, we have auctions where the next bid is lower than previous one. Oh, I said, impossible. She said, check yourself. Okay. So I check here, and I look. And the auction goes. Offer $100, 110, 120, 100. Everything goes nicely. 150. Ah! 145. After 150. But it's impossible. I check my code. My code is checking that the bid must be higher than the previous one. So what's going on? So I'm thinking and beating my head. It's impossible. Then something very interesting I noticed. I noticed that this transaction here, this 140 was entered at 3 o'clock. This was 3:15, and this one was entered 3:15 and 1 second. So I said, how can someone type transaction in 1 second after the previous one? It's impossible to type new bid in 1 second. Oh. Then the light. But sad. But you are running distributed system, not a single user. So what happened is that 2 users logged in simultaneously at 2 servers. And the latest for both of them was 140. So one said 145. Quite valid. The other one, just in a second later over there, said 150. So basically, I have a distributed system. And I have correct local copies of the ledger, but incorrect global ledger. So the problem appears because the system is distributed. And then, when all this is exchanged, then I get invalid sequence. Oh, I say. But here, I have to adjust a little bit my ledger. So according to the rule, that every next transaction should be higher than the previous one. And by the way, every server must independently adjust the copy of the global ledger so that all servers make adjustments in the same way, so that basically all the ledgers on all servers are again synchronized. And this type of independent adjustment of the ledger is called consensus protocol. For me, in this case of auction, the rule of consensus protocol was easy. Just sort transaction in the increasing value of bids. So that was the rule for all servers, and therefore, when I get this case of 2 transactions at 2 different locations, hooked to the same previous, how the terminology goes is, I have in my ledger, I have a fork. And I cannot live with the fork. My ledger must be linear structure and must be the same at all servers. So I had to fix my software. So I introduced consensus. For other applications for which we don't have time, this consensus is not so simple. Because here the rule is simple, increasing value. But there are much more complicated applications. So consensus protocol in a distributed environment can be very tricky. So now it means that I have to take this branch, 140, 145, and then append the next one so that I'm getting ledger linear and fully synchronized. But I had to update my ledger with consensus protocol. Now I'm okay. Seville, sorry, that was a bug. But now you are okay. This will not happen. Reshuffling. She said, very good. So, time goes, couple of days. The call comes. She says, oh, professor, now we have even more serious problem than this shuffling ledger. Oh, I see. What's the problem? Some bits are disappearing. So how is that possible, disappearing, when bit is always added? She said, I don't know. And by the way, professor, you know what? The auction goes, and for some time there is the highest bid, and just to close the auction, this highest bid is removed. And someone else is declared as a winner. Oh, I said, how is it possible? So she said, check yourself. So I checked. So there is an auction. 100, 110, 120, 150. Almost winning bid. But suddenly, this bid, which was 120, suddenly is 151. $1 more than the winning bid. And then my consensus cleaning said, but if the second one is 151, then these here are redundant because they are less than the highest one. Oh, I see. But someone who entered 120, now when he or she sees that 150 is winning, he changed his bid to 151, declared himself a winner. Oh, I see, but someone is cheating here. But, security expert, it's easy for me. As you know, you all know, Security 101, if you have a data and you want to maintain its integrity, this is called data integrity. And we all know data integrity, easy. I'm teaching that 25 years. You create hash, and by the way, you also sign it. So with the hash, you cannot change it. Oh, I was happy I solved this problem. Almost to call Seville, but then it struck me. But wait a second. But this hashing for data integrity will not work. Why? But 25 years, I was teaching that when we write secure email, and I want to give a chance to my partner to validate that the letter has not been changed, then I create hash and sign, my partner verify. But in that email model, I am nice guy, my partner is nice guy, and the rest of the community are all adversaries. They want to change and screw our email. Here, I am the dirty guy. I am modifying the transaction, and the rest of the community are nice. So the model flipped 180 degrees, and hash didn't work anymore. So I was beating my head what to do, and then I said, I still need hash because with the signature I have guarantees of the source of the transaction. But this cannot be the only hash, because if this is the only hash, then this guy will later modify. So I have to add another hash. But wait a second, but where is this transaction going? It's going into the ledger. Oh, but here is my solution. But the ledger should also create additional hash or take the same hash and also sign it. Oh, I was very happy. So basically, the user signs and the ledger server signs. Solution. Oh, but wait a second. But I need keys here, public-private key. And that means I need certificates. Oh, but I know about certificates. I need PKI. But PKI is a third party with block ledger. There is no third party. It's only two of us. No third party. So how can I handle certificates without CAs and third parties and trust in third parties and all this? So I said, well, you have to design certificate system based on blockchain, community-based distributed certificate system. One of my papers. So I designed blockchain-based PKI without CAs, without any trust, just peer-to-peer. And with that, I have two signatures, and now you, sir, cannot modify your transaction. So now my transactions are immutable. They are guaranteed for the content and for the source once they are in the ledger. So my ledger is resource, archive, storage of guaranteed objects. And you can build a lot of applications on that property. So now I have my ledger with multi-signatures. As I was just to call Seville, she calls me and she said, you know, Professor, we have discovered that you can screw the winner not by modifying your transaction. You can screw it also differently. I say, how? Well, actually, you can insert transaction. You don't have to modify your original. You just insert transaction. Oh, but I was close to the solution. So insert transaction, and basically I did have already sequencing value. But if I insert transaction, it means that in terms of time, my transaction is not at the end. Time later, after the previous. The time is after the second transaction. So I need reliable time. You cannot modify time when inserting transactions. Reliable time in internet is a routine job. So basically, to prevent insertions, I extended my protocol with reliable time. So you see, now I have a concept of my ledger, which is distributed, federated, synchronized, secure, with permissions, supports broadcast protocol, consensus protocol, multi-party signature protocol, and reliable time. Far away from the concept of distributed databases. So now my ledger was really foolproof. Works fantastic. No modifications. Guaranteed add-on. No forks. Fantastic. So basically, Seville, now you can use my system. Oh, she said, finally, Professor, so many problems. We even lost our confidence in you. So I said, well, let's try. But now I believe almost 100%. I really don't see any problem. I fixed everything. All right? Then I noticed that she told me, Professor, I have some very good news for you. I said, what? Our application became so popular that we are not only using it in our group, it spread worldwide. So we are getting people all over. Oh, I say, fantastic. She said, maybe yes, maybe no. I said, why no? Broad, open environment. But she said, you know, now our ledger became public. public ledger. I say, yes, I will. You know what? Everybody knows that ledgers could be either permissioned or unpermissioned. So far you use permissioned ledger in a closed environment, but now it's expanded, so it's unpermissioned. She said, yes, it's great, but we really have a problem. Oh, I said, what's again the problem? She said, you know, it's really not so much about your ledger, but we have a problem to close the transaction. I said, can you explain? What is the problem? Well, here is the situation, she said. Someone puts the offer and then bidding. But while we were all with our group, then we all know each other. So someone is paying $150. So very good. So I send you a report, you pay me $150, and everybody happy. But now in the open environment, we are getting some people who say that they will pay $150. We don't know anything about them. Who are they? Are they going to pay? Not pay. So we have now really the situation like the following. The seller says to the buyer, send me $150, then I will send you the report. And the buyer says, oh, send me the report, then I will send you $150. In our terminology, if there is within the group, closed environment, if there is trust, then it doesn't matter who goes first. But if there is no trust, then who goes first is a loser. I said, Seville, I understand your problem and all that, but I don't know what can I do. This is impossible. Who goes first? The loser, in case of cheating. So she said, but you know, Professor, what is the difference between now, our ledger now and earlier? Earlier, we built our application, our transactions based on trust, built in the group. Oh, I said, okay. But now, there is no trust, so the trust disappeared. Oh, I say, yes, I understand that. But she said, but wait a minute. But Professor, you told us that the blockchain doesn't need trust. It can support transactions without any trust into any party. Oh, I say, Seville, yes, you're right. So, Professor, there is no trust, so can you solve our problem? I say, maybe she has some idea. So I said, okay, so she says, like, why don't we use ledger? So I said, let me use the ledger. So I said, how about that the guy uploads into the ledger the report, and she uploads money, and then he downloads money, and she downloads report. So basically, now I said, let me try to use the ledger. He uploads report, she uploads money, then he downloads money, and she downloads a report with a ledger. But I say, wait a minute, don't fool yourself. Because if there is cheating, this still doesn't work. Because he uploads report, she downloads report. It doesn't pay. So just exchanging, not directly, but through the ledger doesn't help. So I say, wait a second, let me see, where is the glitch here? So, seller uploads the report. Buyer uploads payment. Everything goes smoothly and honestly. Seller downloads payment and buyer downloads report. But I said, but wait a minute. But cheating appears if she can download report without previously paying. Oh, so I have here a protocol which has mutual dependency as a sequence of transactions. Oh, now my ledger can synchronize and control that. So the ledger will say, if you upload report, then you, lady, cannot download report until you upload money. Or, for seller, if the lady uploads money, sir, you cannot download money until you upload the report. So now my ledger becomes basically the authority. to enforce transactions that otherwise need trust. Contrary to all other ledgers, those in the second group, people who know what the ledger is, they say ledger is distributed database, and by the way, it has all the transactions, and it basically receives transactions and downloads transactions and then keeps the sequence. And no, you cannot do peer-to-peer transactions in an open environment if the ledger doesn't play active role. So blockchain up and down is not sufficient. Ledger up and down with control is sufficient. So my ledger now must enforce control. What is the control? It's basically agreement between these two. If you pay, I will send you the report. If I pay, you will send me the report. Very good, agreement. So this agreement can be structured as a simple document. We call it smart contract. What is smart in this contract? Contract is who am I, who are you, what is the subject, report, what is the price, see? And there are just two checkboxes. And this smart contract is maintained by the ledger. And then now you understand everything. When I upload, the ledger will tick. But obviously, you cannot download My Lady unless both boxes are ticked. So you say download report, although the guy uploaded, the ledger will say no, because the box is not ticked. So how can I tick the box? The lady says, you upload the money, and then the ledger will tick the box. So tick, tick, download. Document with two check boxes handled by the ledger. So now I have the complete system where even I can do two-party transactions through the ledger, controlling this through the smart contract. Very good. I know that now Seville will be happy. But I'm not happy. Why? Because now my system has a third party. My system is handling storage. I became Dropbox. I became SA Banken. You pay and the bank, I don't want this ledger to be, no, I want peer-to-peer. So I say modification. I generate key, encrypt report, send to her. And then I just put a key in the ledger. And she can, details, she can get the key if she buys it from the ledger with her money. So now my ledger not only handles public key cryptography, you remember my certificates, my ledger now handles also private keys. And if I roll back, as you all know, in order for me to have a certificate, I must have first my identity. So in my design, my secure blockchain ledger is handling blockchain identities that are used for blockchain certificates, that are used for protocols for secret keys, that are used for encrypting of objects over the ledger or peer-to-peer. This is what I call secure ledger. There are some companies who say, I have account, you have account, so they call these accounts smart contract. So if you transfer a couple of virtual currencies from your account to my account, they say money transferred from one contract to another contract. But tomorrow when you read that, you are not in group 2 anymore. You say, who are you fooling? It's just a transfer between two accounts. It's not smart contract because we are now in 0.9% of people. Okay, so now with all of that together, I have the complete system. So now I check myself all of that. very good. Everything covered, secure ledger, peer-to-peer transactions, all kind of applications, everything great. But then I'm facing a little bit of problem how I can call my ledger, because the whole world calls ledgers, you will read in all these reports, ledgers can be either permissioned or unpermissioned. That is open for everybody or restricted. Alternatively called, they can be private or public. But you say, wait a minute, but this what I just explained to you doesn't fit that. Because during auction, my ledger is unpermissioned. Everybody can post and everybody can bid. But once auction is closed, then I have to know who is the partner and authorize transactions and all that together. So for payment, my ledger is permissioned. Oh, so I said to myself a year ago, but sad, there is no permissioned ledger or unpermissioned ledger. Ledger is ledger. There are permissioned applications and transactions, and there are unpermissioned. When I send you email, email is email system. Is it secure email system or not secure? Depends on my email letter. So if I'm using encrypted email with you, then our application is secure. Between two of you, application is not secure, but email system is not secure or not secure. It's email system. So from now on, when someone tells you, oh, I know everything about blockchain ledgers, they can be permissioned, unpermissioned, you can say, okay, you need some time to learn. So, my ledger is not permissioned, is not unpermissioned. It's misconception. My ledger is hybrid. For some applications, if you need security, you can enforce security with your applications. If you don't need, then you run public ledger, but ledger doesn't have anything to permission or unpermissioned. So now you know everything about my ledger. Perfect concept, perfect design, perfect implementation. We are soon as a company releasing this ledger, July, August.